Let's start with sensors. But before we do sensors, got to have a little bit of an introduction to some real basic solid state components. So solid state components, first of all, for the most part, they are electronic devices that have no moving parts. They consist of diodes, transistors, silicon controlled rectifiers, which are SCRs, and Triacs. Now there's a lot of other solid state devices. There's integrated circuits, there's field effect transistors, unijunction transistors, Zener diodes. I mean, there's just a lot of different solid state devices, which are also, by the way, called semiconductors. So if you ever hear me use the term, oh, well, that's a semiconductor, I mean that it is a solid state device. So diodes are used like all over the place, and they're used in multiple locations and multiple applications within control circuits. One of the applications that we're going to talk about a little later in this course is DC flyback protection. Some of you may have heard of this, some of you may have not. It's also called inductive surge suppression, and it's used on inductive loads. That is when you have a DC circuit and you have an inductor as the output device. That's an inductive load, and we'll talk about why they're used and why you have to protect yourself from that. There's also transistors. Transistors are commonly used as switches in DC control circuits. So the transistor becomes the switch, but there's no moving parts. There's no contacts that open and close. And then there's silicon controlled rectifiers and Triacs. And these are also switches that have no moving parts, no contacts, no wipers, no poles. But these guys are used in AC control circuits. So let's look at a diode. In a diode has two leads on it, and those leads are the anode and the cathode. Take a look at the symbol. It's this arrow with a line. The arrow end of it is the anode. The cathode end of it is the line. Look at the arrow. The arrow's showing the direction of conventional current. Now, we briefly talked about the difference in current flow. Remember, conventional current flows from positive to negative. Electron flow flows from negative to positive. We really don't care which way the electrons are flowing for most of what we do. However, the solid state symbols are drawn so that things like these arrows point in the direction of conventional current. And also, when people talk about solid state devices and they describe current flow, they're talking conventional current. So that's pretty much what we're going to be using in our discussions. So diodes, when they are conducting current, the term for that is called that the diode is forward biased. Now, a diode will conduct current when the anode, that's this guy here, this is the anode, this is the cathode. So this diode will conduct current when the anode is 0.7 volts more positive. Notice how I word that, more positive than the cathode. And when that happens, current will flow through the diode, and the diode is considered forward biased. Notice how I show a big plus sign here and a little plus sign there. This side is more positive than this side by 0.7 volts. Can be more than that, but 0.7 is when the diode starts to conduct, or when the diode's conducting, you got 0.7 volts. The diode will not conduct current if the anode is not 0.7 volts more positive than the cathode. So when the anode is less positive than the cathode, the diode will not conduct current, and it's considered to be reverse biased. So depending upon the level of bias I have across this, or the voltage drop across this device, I can have current flowing or no current flowing. Geez, it's a solid state switch. There's also this device called a transistor. Transistors are also used as switching devices in DC control circuits. They're very similar to a diode. In fact, they're very similar to two diodes wired together. Like a diode, it requires a 0.7 volt bias on the different elements of a transistor to allow current to flow. So when I look at a transistor, there are two polarities. One is called an NPN, and it's equivalent to, and that's what that sign means, a term called sink. And there's a PNP, which is equivalent to a term called source. These terms, sink and source, define current direction. So sink and source are terms that define current direction or current flow direction. So if you look at the transistors, there's two polarities. There's an NPN transistor, there's a PNP transistor. Transistors consist of three elements. There's an emitter, a collector, and a base. Both polarities have the same type of leads. The base lead, these are switches. So the base lead, I would like to call it the actuator. It's what opens and closes this switch. Now there's no physical disconnect. It's just turning the electron flow off, or turning the current flow off between the collector and the emitter. So when you look at the current flow, the arrows here on the emitter point in the direction of current flow. So I've got current flowing out of the emitter, I've got it flowing into the collector, and it's flowing into the base. This requires 0.7 volts. This requires 0.7 volts. On the PNP, notice the arrow on the emitter. Current's flowing into the emitter, it's flowing out of the base, and it's flowing out of the collector. So it's a matter of current flow. And there's two different polarities, NPN, PNP. And again, NPN, another word for it is sink. And PNP, another word for it is source. As I mentioned, field effect transistors, FETs, are also switches. You don't have to know how any of these devices actually function. They're transistor type devices. I showed you some of the symbols that you might see that represent field effect transistors. and then the SCRs and the Triacs. Everything we saw before this works primarily with DC. SCRs and Triacs, however, are more common when you're in AC circuits. And again, it's a switch. An SCR, and this over here is the SCR, silicon controlled rectifier. It looks like a diode. It has an anode and a cathode, but here it has a third lead called a gate. And this gate is the actuator. So when you put a voltage on the gate, I can turn this device on and off. A Triac is nothing more than two SCRs, what's called back-to-back. You don't have to remember that. Here's the symbol for it. It has a main terminal 2 and a main terminal 1, and it also has a gate, and that's the actuator. So when a voltage is applied to the gate, it can turn this Triac on to have current flowing. When the voltage goes away on the gate, I can make the turn off. So they're AC switches. And that's all I want to say about solid state devices. And I bring it up so that you understand at least the names and the terms and the fact that current will only flow one direction through a solid state device.